Today, we're going to pull back the curtain on an invisible force that literally powers our world, from massive factories to the internet itself. It's called three-phase power, and you see its handiwork everywhere, even if you don't know it. It's kind of the unsung hero of the electrical grid, and it all boils down to a surprisingly simple, really elegant design.
I mean, you've seen them, right? Those giant metal towers marching across the countryside. And if you look closely, you'll almost always see wires in sets of three. Have you ever wondered why? Why three? It's not random. That number is the key to one of the most brilliant and efficient engineering solutions ever created. So let's figure this out.
Okay, so to get why 3 is so special, we first have to understand why 1 isn't always enough. Let's start with something we all know, the outlet in your wall. That's single-phase power. It's just one wave of electricity, an alternating current sloshing back and forth. And you know what? It's great for running your lights, your TV, your laptop. Simple, reliable, gets the job done. But what happens when you need to power something way, way bigger? Well, that's where we hit a snag. That single wave, it has a hidden weakness. Because the voltage goes up, then down to 0, then up again, the power it delivers isn't constant. It pulses. It hits a peak, then drops all the way to nothing, over and over, 60 times a second. For a light bulb, who cares? You don't even notice. But for a giant industrial motor, that's a huge problem. It's like trying to run a freight train with a one-cylinder engine. It's going to be jerky, incredibly inefficient, and just wasteful. There had to be a better way. And that better way is, yup, you guessed it, three-phase power. Instead of just trying to force more power out of that one single pulsing wave, some genius engineers had a brilliant idea. They asked, what if we used 3? Now, a balanced three-phase system isn't just about grabbing 3 random power signals. No, it's a very carefully arranged set. You've got 3 ways of electricity. They all have the exact same power, the same voltage, and the same frequency. But, and this is the absolute secret sauce, they are deliberately perfectly out of sync with each other.
Picture this. Phase A starts its cycle. Phase B just hangs back and waits for exactly 1/3 of a rotation, that's 120 degrees, before it gets going. Then Phase C waits another 120 degrees. They're always chasing each other in this constant, perfect rhythm. They never step on each other's toes. It's like a perfectly choreographed ballet of electrons.
So, this perfect 120-degree offset, it's not just for looks. It creates a mathematical property that is so profound, so powerful, it forms the backbone of our entire global electrical grid. And the property itself is, well, it's pretty wild. And there it is, the aha moment. Because those 3 waves are so perfectly offset, if you stop time at any single instant and add up their voltages, the total is always exactly 0. It's incredible. As one wave is peaking, the other 2 are in just the right negative spots to cancel it out completely. Now, I know what you're thinking. How can something that adds up to nothing be so powerful? Right? It's a totally fair question. If the voltages just cancel each other out, where's the advantage? Well, it turns out this zero-sum game has 2 massive, world-changing consequences. To really get it, though, we have to see how we actually connect these waves to a machine in the first place. To actually use these 3 waves, you gotta connect them to something, like a big motor. And there are 2 main ways engineers do this. And they're named for the cool shapes they make on a circuit diagram. The star, which is also called a Y connection, and the delta connection. So the Y connection, or star, does what it says. It brings all 3 phases together at a common center point. You see this a lot in power distribution systems. The delta connection, on the other hand, hooks the phases up end to end in a closed loop, like a triangle. That's super common for heavy-duty industrial motors. But here's the thing. No matter how you hook them up, they both let you tap into that same 3-phase dance to unlock some truly amazing benefits. Okay, so we've got our 3 perfectly balanced waves. We've got a couple of ways to connect them. Now, let's get to the payoff. Why do we go through all this trouble? What are the game-changing benefits that make this system the undisputed champion of the world? There are 2 really, really big ones. The first payoff? Well, it takes us right back to the problem we started with. Remember that jerky, inefficient, one-piston engine of single-phase power? 3-phase power completely, totally fixes it. You see, even though the individual voltages are still going up and down, their combined power delivery is perfectly flat. It is absolutely constant. It never, ever drops to 0. As one phase starts to dip, another is rising to take its place. It creates this beautiful, smooth, uninterrupted river of energy. For a big motor, this is a dream come true. It means less vibration, way higher efficiency, and a much longer life. It's the difference between that clunky one-piston engine and a perfectly balanced, silky smooth V6. Now, that constant power is huge, but the second payoff? This one is arguably even more important. This is the reason three-phase power took over the entire planet, and it all comes down to pure, hard-nosed economics. We're talking about saving an unbelievable amount of material.
Okay, get this. To deliver the same amount of power with the same efficiency, a single-phase system would need 33% more copper or aluminum for its wires than a three-phase system. Just let that sink in. 33%. Now scale that up. Think about the millions of miles of power lines that crisscross the globe. We are talking about saving literal mountains of metal and billions upon billions of dollars.
And that's why, at the end of the day, the choice was obvious. Three-phase power isn't just a little better technically, it's economically unbeatable. That incredible combination of constant power and massive material savings made it the only real choice for building the modern world we live in. Those three wires on the power lines, they're a symbol of profound, beautiful efficiency. So next time you're out and you see those three wires strung up overhead, you'll know the elegant secret that they're carrying. A perfectly choreographed dance of energy that is both incredibly powerful and unbelievably efficient. You know, it makes you wonder, what other huge complex problems out there could be solved by a similarly simple, balanced three-part solution? Thanks for tuning in.